Hello everybody. So in this video, I'm going to tell you a little bit about some area and circumference, arc length, things like that, equations for a circle. I'm going to walk you through the formulas, how to use them, what the different parts mean, and then in another video, I have some example practice problems, some extra practice problems for you. Okay. So let's go ahead and jump right into it here. Okay, so some of these things you likely will have seen before, right? Because this is mostly just area and circumference of a circle, which you should have seen, I'm hoping, in middle school. Okay, so just as a quick reminder / overview for you. So the area of a circle is literally just all the space, right, that makes up a circle. Okay, and in order to find the area of a circle, so the area is like just this whole thing in here, right? The formula for the area of a circle is pi r squared, where r is your radius okay, and then pi is a never-ending irrational number, but we usually abbreviate it with 3.14. Okay, all right, so I want to do an example for you here. So here's an example. Okay, so I'm going to say, let's say, for example, I have a radius of 6 inches, and I want to know what the area of that circle is. Okay, so the area of that circle is pi times 6 squared. Now, my advice when you're doing these types of problems is to do everything except the thing with the pi first, right? So like I would do 6 squared first, which is 36, and then just leave the pi on the end. So sometimes questions will ask you to do things or give your answer in terms of pi. That's what this is. That's what that means, right? Where it's just a number with a pi on the end, right? So if I was to leave my answer like that, I want to make sure that I put units in my answer, right? Since there were units in the question, okay? But then you can also then multiply the pi through. So the reason that I have you guys look at this and do this in terms of pi is because that way you don't have as much rounding error, right? Because once you get to this point, right, once you get to this point where you have your answer in terms of pi, then all you have to do in your calculator is type the number in front of the pi. So in this case, 36. Press the multiplication button, and then there is a symbol, or there should be a symbol on your calculator that is this symbol, the pi. So then you literally can just say times pi, and it will multiply it by the entire number pi, like with the really long decimal, rather than just multiplying it by 3.14. So you're going to get a more accurate answer that way. Okay, so when I did this in my calculator, I got 36 times pi is 113.097. So I'm going to round up to 0.1 inches squared. Okay, if you had just multiplied by 3.14, then your rounding would have been a little bit different. Okay, all right, so that's area, right? Then next thing we want to talk about is circumference, which is another thing that you likely have heard of before. Okay, but I'm going to do a little bit of drawing here. Okay, so circumference is just the area or the length or like around the circle, right? So the reason I'm drawing both a diameter and a radius is because you can find circumference using both of those things. So the circumference is quite literally just the outside of the circle here. Okay, and there are two formulas for circumference. Okay, but they get you the same thing. So the circumference, which we usually abbreviate with a big capital C, you can either find circumference by doing 2 pi times the radius, or pi times the diameter. And I'm hoping that the two of those things, like, it kind of makes sense why we have both, right? Because if you look at a diameter has 2 radii. So we're replacing d, diameter, with 2r, 2 radii, okay? Right, so remember, r, again, still stands for radius, and d stands for diameter. Okay, so I'm going to do an example for you here. Okay, so again, we're going to go with our example of my radius is 6 inches. Okay, so let's say radius is 6 inches. Right, so since I have the radius, I'm going to choose this equation. Right, so my circumference is 2 pi times 6. So again, you want to deal with everything that isn't the pi first, and you're just multiplying all of this together, right? So 2 times 6 times pi. So I'm just going to multiply 2 and 6 together and get 12. And then if I leave the pi on the end, right, this would be your answer in terms of pi, right? But I have to make sure I put my units on there. Now, circumference is like a distance, right? You can think of like if you think of like a circle, almost like a lake, for example, right? The circumference is you walking around the outside of the lake, like doing one full lap around the outside of the lake, whereas the area is like all the water inside the lake, right? That covers it, right? You know, on the surface, right? So the reason I bring that up is because you hopefully notice that your units change a little bit, right? For circumference, my final answer is in inches, whereas area, it's in inches squared, right? So that's going to be the case for any area versus a distance, right? So area of any shape is always going to be in units squared, right? Whereas a distance is just inches, right? Because this is like 1 dimension and this is like 2 dimensions. Okay. Now, I can, once I have this in terms of pi, then again, all I'm going to do in my calculator is do 12 times, and then I'm going to hit the pi symbol. And when I do, right, I'm going to get a more exact answer that way. So I got 37.699. So I'm going to round that up to 37.7 inches. Okay. All right. So that's area and circumference. Now, the other two things that we need to talk about are area of a sector and arc length. Okay. So area of a sector, right? You can almost think of this like if you're cutting a pie or like a pizza or something like that, and you're like taking a slice out of like a pie or a pizza, right? So a sector is just like a slice of your pie or your pizza, right? Okay, so what we want to know when we're finding the area of a sector is how much area does just that part or just that portion of the circle take up, right? And you'll notice in my drawing this time, I indicated not just the radius, but this N right here, which is the central angle, okay? So here's how you find the area of a sector, okay? So the area of a sector is N divided by 360 times pi r squared. Oops, hold on. That pi looks crazy. Let's write that a little bit better. Okay, where N is the central angle. Okay, which I'm hoping you remember from the last unit. Okay, so essentially what you are doing here, okay, is you are taking a fraction right? N over 360, a fraction of the whole area, right? Because we have our area formula right here. And then we just want to know here with N over 360, how much of that circle, what proportion of that circle do I care about, right? Which one, what part am I examining, right? And the easiest way for us to figure that out is to look at the degrees, right? This of the central angle that is associated with that sector, right? Because there's 360 degrees total in a circle, right? So the central angle is like the part of the circle that we care about, right? So it's going to give us what proportion or fraction or percentage of the whole area that we want to find, right? You're basically doing part over whole and part and whole, okay? Right? But once you have the information, like don't let the fraction be the thing that freaks you out. Okay, once you have all of this information, all you have to do is plug the information into the formula and simplify it. Okay, so here's an example for you. Okay, I'm going to tell you that the central angle of my section here, of my sector, is 36 degrees, and I'm going to tell you that the radius is 5 feet. Okay. In most problems, they're going to give you all the information that you need, and you just have to plug it into the formula and simplify it. Okay, so let's do exactly that. So the area of my sector is 36 divided by 360 times pi times 5 squared. Okay, and I'm just going to go ahead and do this in the order that I normally would do any order of operations problem, right? So I'm going to deal with my exponent first. Okay, so I have 36 over 360, and then pi times 25. Okay, and then the next thing you can do is figure out what this fraction is. You can reduce this fraction, or you can plug it straight into your calculator if you wish. So I'm going to reduce the fraction just so that you can kind of see what that looks like, right? So 36 over 360, the greatest common multiple here between these two is 36. So this becomes 1 out of 10. And then I have 25 pi. Since all we're really doing is multiplying everything together, you can switch the order of like the numbers and the pi. It's not going to matter. You're going to get the same answer either way. And typically, we like to write all of our numbers first and then you stick the pi on the end. That's just like the proper way to write things in math when you're dealing with pi, right? So then I can do, okay, 25 divided by 10 is 2.5. So my final answer here in terms of pi is 2.5 feet. Oops, sorry, I forgot my pi. Oh my gosh. It's 2.5 pi feet squared. That actually looks crazy. Hold on. I wrote that feet squared way too close to the pi. Okay, so 2.5 pi feet squared. So that would be my answer in terms of pi, okay? But again, once you get to that point, all you do is go to your calculator, say 2.5 times, and then hit the little pi symbol, and then press equals, and it'll give you the number, right? The long decimal value. So I got 7.854, so I'm just going to round that to 7.85 feet squared. Now, here's the deal, y'all. If I was going through this example and when I got to this point where I was dealing with the fraction and stuff, if you were going to yourself, okay, that's like a lot to handle, like I don't want to have to deal with like reducing a fraction, you don't necessarily have to do that, okay? Because you're never not going to have a calculator, okay? So if you want to, rather than going, so I'm going to put a little asterisk right here, okay? Rather than actually having to reduce this fraction, what you can do in your calculator is just do 25 times 36 and then divide that by 360. Okay, that's going to get you right here to this step, and it will get you the number that should go in front of the pi. Okay, right? Because technically, this divided by 360 applies to this whole thing, even though I'm not writing it that way. The 360 divides everything that you see here, the 36, the pi, and the 25. Okay, so if you don't want to deal with reducing the fraction, just let your calculator do the work for you. Okay, all right, so that's area of a sector. The last thing that we need to talk about in this video is arc length. Okay, so very similar to the area of a sector, right? If I draw a sector here, I have my central angle and my radius. Okay, but the arc length is not like everything inside of that sector. It's just the part of the circumference on the outside. Now you may be thinking, wait, haven't we already done this, right? Isn't the rule that if we know what the angle is, the central angle, then that means this arc out here has the same measurement? That is technically true, okay? But that is arc measure, not arc length. Arc length doesn't have a degree, right? A length is an actual distance. Like think of it like a physical distance that you could walk. So like inches or feet or yards or miles, right? So when we're talking about arc length, that is different from arc measure. What we did in the last unit was arc measure, meaning how many degrees was that portion of the outside of the circle. Here, we're trying to find how many inches or feet or yards or miles, right? What the actual like walking or movement distance would be, okay? So if you're asked about arc length, you have a formula that you have to use, okay? So arc length uses the following formula. Very similar to the area of a sector. We're looking at n over 360. So this is like the fraction or the percentage or the proportion of the entire circumference that we're looking for. Okay, and then you multiply it times 2 pi r, which is the whole circumference, okay? So very, very similar formulas here, right? We have this fraction, n over 360, and then for arc length, you just use the formula for the entire circumference, whereas for area of a sector, you use the formula for the area of the whole circle, okay? But it's very similar ideas regardless, right? And n here is still my central angle. Okay, so let's use those same numbers from my previous example with area of a sector as our example here. So again, I'm going with a 36. Ooh, sorry guys, my mouse slipped there. That 3 is crazy looking. Okay. Oh, and it also just refuses to erase. Fun! Okay, so 36 degrees for my central angle, and I'm still going with my radius is 5 feet. Okay, so my arc length, okay, and we don't really have just a letter that we use for arc length, just because area and arc both start with A, so it can get confusing. We usually just write out arc length. Okay, so I'm going to plug these values into my formula. So it's 36 divided by 360 times, and then it's 2 pi times 5. Okay, so I'm going to deal with what's inside my parentheses first. Okay, so that's still 36 over 360. And then 2 times 5 is 10. And then I'm going to leave my pi. Okay, so now at this point, you can either reduce the fraction, which would give you this, 1/10 times 10 pi. Or you can just plug all of this directly into your calculator, right? You can do 36 times 10 divided by 360. It's going to get you this exact same answer, right? Either way. So here, 1/10 times 10 is just 1, right? So all I have left is this is pi feet. So that would be my answer in terms of pi, right? And then pi is the number 3.14. So 3.14 feet if you round, okay? And just like circumference, right, my units here are just regular feet, whereas for area of a sector, it's feet squared. Right? Remember, always when you're dealing with an area, your final unit should be something squared. Whenever you're dealing with a distance, it should just be that regular unit. All right, so that is it for arc length and sector area. Okay, in the next video, I'm going to do lots of other example problems for you. I'll do a couple where you have to work backwards, right? So one thing I want to say before I end this video is once you have this formula, very similar to all of the other circle formulas that we've been looking at, in some problems, they may give you, for example, the arc length and ask you to solve for the radius, for example, right? Or ask you to solve for the central angle, okay? Whether or not they give you everything you need on the right side of the equal sign and ask you to find arc length or sector area, versus if they give you the arc length and ask you to solve for something, the formula remains the same, right? It's just if they give you the arc length, you kind of have to work backwards a little bit and do some algebra in order to solve for the thing that you're missing. Whereas the examples that I've given you here, you haven't really had to solve for anything, right? You've mostly been simplifying and using your order of operations, all right? So I'm going to sign off here. That is it for this video, and I will see you all in the next one for some examples. Bye, everybody.